Welcome everyone. I hope everything good. In this lecture, we will be determining the direction angles for the force given here, which magnitude is 75 pound. Here a beam is given and the force is acting in this way. Here you can see that these are three direction X, Y, and Z. These are three axes, means we have 3D structure and the force is acting in 3D plane. So we need to determine the direction angles for this force. What is the meaning of direction angle? It is the angle from x-axis, y-axis, and z-axis to the force. So we need to find this angle, like it is the angle from the x-axis to the this force. It is termed as alpha. We need to find alpha, and we need to find beta, which is the angle from the y-axis to the this force, and also gamma, which is the angle from the z-axis to the this force. We need to find the alpha, beta, and gamma. What is alpha? Alpha is basically the angle from the x-axis to the force. Its formula is equal to cosine inverse fx divided by f. It is formula for the direction angle for the alpha, which is start from the x-axis to the force, and beta is the angle from the x-axis to the force. Which force? This force, which is given 75 pound, and it will be equal to cosine inverse fy divided by f. And for beta, it is the coordinate angle, coordinate direction measured from the z-axis to the force, and its formula is equal to cosine inverse fz divided by f. So these are basically the formulas for the alpha, beta, and gamma. What is the value of fx, fy, and fz? We don't know for this question. We need to find the value of fx, fy, and z. These are basically the coordinates, perpendicular coordinates for this force given in 3D, and its magnitude is 75 on. What it means that we need to find the value of fx, fy, and f of z. Then after that, we will be able to solve for alpha, beta, and gamma. So we already know the value of f, and we only need to find the value of fx and fy. So for fx, here you can see that the structure is a bit looking very complex. So I will be resolving this question in such a way that you will be able to solve very easily. So we will be solving step by step. Means here we have two triangles, one this triangle and another this. So we will be applying triangles in such a way that we will be applying trigonometry in one triangle, then applying trigonometry in another triangle. Then we will be able to solve for the fx, fy, and fz. Then after we will be able to solve for alpha, beta, and gamma. So now I will be drawing this triangle here. You can see that this triangle here, somewhere here. Then after that, we'll be able to solve, find the value for this component and this component. Here you can see that in picture in the question, it mentions that this side, this side, this side is basically the component of this force along the x and y plane. Remember this. This side is basically the component, the projection or the shadow of this force on the xy plane. And this is the component of this force along z-axis. You can see that this side is parallel to the z-axis. So this will be the fz, and this is the fxy, means this force component along the xy plane. So from this fxy, we can use then this triangle, and then we'll determine fx and fy. So first I will be drawing this triangle here. So I have drawn this figure here. You can see that this force will become equal to F, which is 75 pound, and this blue force will be the projection of this force along x and y plane, and this force will be Fz. Why? Because if you can see that this force is parallel to this side. So this side basically the component of this force along z-axis. You can see that this force is actually parallel to the z-axis. So this will represent the z component of this force. And this is the xy plane. So the force component of this force along this plane will be considered as fxy, means fxy plane force. So from this, we will be finding the fx and fy separately with the help of this triangle. So I will be taking this after solving this, finding the value of f of xy and fz. So now here you can see that the angle here, you can see that it is 30. So this angle will also be 30. Basically, I have drawn this figure here. Now I need to find the value of f of xy and fz. So for f of xy means the projection of this force along xy plane. So this will become equal to, I will be applying the cos theta formula. So f times of cos theta. So what is the value of f, which is 75, and the theta value, which is 30. So I will plugging here. So 75 times of cos 30 degree. So the xy, this represents the xy force. So the fxy will become equal to 64.95 pound. So this is the projection of this applied force, given force on the xy plane. So now I need to find the value of fz. So for fz, I will be applying trigonometric ratio sine theta. So fz will become equal to f times of sine theta. So putting the value of f and theta, the value of f is 75, theta value is 30. So the fz value will become equal to 37.5 pound. What will be the sign? Here you can see that this force is acting downward, so it will be negative. Remember this, don't forget to miss the negative sign. If you miss the negative sign, so your the projection angle gamma will be incorrect. So we found the value of fz and fxy. What we need to determine, we need to determine the value of fx and fy separately. So now I will be finding the value of fx and fy. Now I will be using this triangle only, means this second triangle. So now I will be drawing second triangle here, then I will be finding the value of fx and fy. So you can see that I have drawn this figure here, this triangle here. This side is fxy, which value is we found here, which is 64.95 pound. And this side is here you can see that this side and this side is parallel. So it means that both sides will become equal to the fx, because it is actually parallel to the x-axis. So this and this side are parallel, so it will be fx, and also this side is fy, it is along the y-axis, so it will be fy. Also we know this angle, which is 45-degree. So all thing is known, so we just applying the trigonometric ratio will be find, we can determine the value of fx and fy. So for fx I will be applying sine theta, so fx will become equal to the fxy, the projection of the force, f force, times of sine theta. Now the angle is this 45-degree, so it will be fxy will become fx become equal to the value of fxy, which is we found earlier 64.95 sine 45. So the fx value is 45.93 pound. Now I will be finding the value of fy. So for fy, I will be also applying trigonometric ratio in this triangle. So the fy component will be the cosine cos theta, because we will be using cos theta because it is adjacent to the perpendicular ratio. So fx, the projection of the force fxy times cos theta. So putting the value of fxy, which is 64.95, and cos theta value is 45. So the fy value will become equal to 45.93 pound. So here you can see that fx and fy both are equal, because sine of 45 will equal to cos of 45. The angle is 45-degree. That's why the component of this f force along x and y axis will be equal. So we already found the value of fx, fy, and fz. So now we will be applying the formula for alpha, beta, and gamma. So formula for alpha is alpha will become equal to the cosine inverse of fx divided by f. So alpha will become equal to cosine inverse fx value we already found here. You can see that 45.93 divided by F, which is 75 mentioned in question, given in question. So the alpha value will become equal to 52.24 degrees. Now we will be applying for using for theta. So the theta beta, for beta the formula is cosine inverse Fy divided by F. So putting the value of Fy and F, so the cos inverse will be 45.93 divided by 75. The value of Fy is 45.93. So the beta value will become equal to 52.24 degree. Now we will be doing calculation for the gamma. For gamma, the formula is gamma will become equal to the cosine inverse Fz divided by F. So gamma will become equal to the value of Fz is minus 37.5 divided by 75. So the gamma value will become equal to 120 degree. So we found the coordinate direction angle for this force. The alpha is 52.24, the beta, which is the direction of this force along from y-axis to the this force, which is 52.24, and the angle from the z-axis to the given force, it is represented by gamma, and its value is 120 degree. So I hope you understand this question, and I hope you can apply in further in the upcoming questions related to the coordinate direction angle. So here it looks very complicated. I resolved in very easy way in two triangles. I found the value of Fz and Fxy, which is a projection of this given force along the xy plane. Then from the another triangle, I found the value of Fx and Fy. Then after I used the formula for alpha, beta, and gamma, so I reached to the required answer for the coordinate direction angles for this force. So I hope you understand. Thanks to everyone.